Topic is on IoT and metaverse. So we are going to see how this two technologies, IoT and metaverse, are integrated, or what are the things that we can do with metaverse and IoT will be the topic that we are going to study today or discuss. So I need some responses from your understanding about IoT that would help me to take this talk in a better level. So can some of you can quickly give your views on IoT, please? Are you getting any chat? Any responses in chat? Okay. Am I audible to you all? Okay, I could get it as the combined aspect of digital environments. I could see some chat. Yes, thank you for your response. Okay, hopefully, I think I'm audible to everyone. Fine. So, going further, today my topic is on IoT and metaverse. Metaverse totally deals with the logical or illusion, we can say, where it is not physical, you cannot feel it or you cannot touch it. It is not like how you walk. It will give you where it's like an illusion that you're walking on a mountain or you're on a building or you're playing some games. So most of the time, this AR, we use the techniques like augmented reality, AR, virtual reality. So the name itself specifies that it is virtual reality. So it's like not actually real, but it gives you an experience where it is really happening. That's what we call it as virtual reality. So metaverse is a place where all these AR, VR, extended reality, all these concepts are given to you. Maybe you may be experiencing a game, or you may be considered as an avatar and then doing certain operations, or it may give you like you are as if playing a game or you are walking down from the top of a building. There are different technologies or different types of games that you enjoy, but most of the times we cannot directly do it. Maybe you use some gadgets, maybe your Oculus device that you put it on your eyes and then try to get that experience. Or sometimes you feel like picking a ball and putting it inside. You could have experienced so many views like 5D or some thrilling games in malls nowadays. If you go there are some AR VR games that are given to you. So we all enjoy it, but we know that it is not reality. That is the reason we call it as virtual reality, and metaverse deals mostly with this virtual reality concepts. But what I'm going to do with Internet of Things and virtual reality previous speaker has made it very simple for me because he has already spoke about all the different technology enablers that are helpful for metaverse. So he was talking about blockchain. Yeah, blockchain is one of the important technology which was like a technology enabler for metaverse. Apart from your blockchain technology, if you could see, your artificial intelligence plays a vital role, machine learning plays a vital role in metaverse. Apart from that, the major area where we contribute is from IoT. So the new buzzword or the recent words, we started with internet computing. Now we started with Internet of Things. What Internet of Things actually mean, we all might be knowing, or many of you might be working with, or you might be experiencing certain things in your home. It may be a smart home, or you may be controlling your washing machine from your mobile phone, or you may be controlling your fridge, or you may be watching your CCTV camera, and you may be talking to your kids sitting from your home. So these are all the things that are like some of the advancements or IoT, we can say, where gone are those days where only my computational devices can be connected to the internet, right? So before, when the internet was invented, we could say that only my laptop can be connected to internet, or my tablet or desktop PC can be connected. There should be a proper Ethernet connectivity mechanism to my system. Then I can connect with the help of cables. And all these things were there before, but now it is not the case where we have a seamless integration of internet through Wi-Fi. So almost every home we have the concept of wireless fidelity or a Wi-Fi router or a modem we have, and we connect many devices seamlessly. almost in any home, if you take minimum 3 to 4 mobiles, we connect to our Wi-Fi. Our TVs, our smart TVs are connected to the Wi-Fi, or even all our electronic appliances are connected to the Wi-Fi, and we could connect anything to the internet. Even if you're sitting in a car seat, it senses whether a particular person is sitting or not, and then it gives you alarm stating that there is the person is sitting in your car, but still the seat belt is not fastened. There is no physical mechanism that is checking it, but still sensors are there attached with your car seats, which senses that there is a pressure that is put on your seat, but still there is no seat belt being fastened. So it represents, or it thinks, or it gives you certain meaning. Sensors can actually collect some data and then pass it on, and based on that data we do certain operations. I'm talking about a very basic example of your car seat belt, but at the same time, these sensors or actuators are being fitted in every place. Even if you want to make your t-shirt smart, you can have some wearable things in your t-shirt. It can read certain parameters. Even if you want to make your footwear smart, you can do it. You can attach some sensors. It can check the pressure, how much you insert on your footwear, and there are so many things that you can do. Even if you want to make a table or a chair to think, you can do it by attaching some sensors. So what I mean to say by Internet of Things is like anything in the world can be connected, but it cannot be directly connected to the internet, but there are certain mechanisms that we need. So there should be a microcontroller or a software hardware that should allow anything to connect to the internet. At the same time, along with the microcontrollers, the main things that we have are called as our sensors and actuators, which does this. So IoT is a separate area where we have a lot of advancements going on, and we have coined the term Internet of Things, meaning that anything can be connected to the internet. But now we have gone to the level where it is not anything can be connected to the internet. We call it as Internet of Everything. It's not only IoT. Now we say that it is Internet of Everything. Anything you see, you can connect it to the internet is what we could achieve that. So there are certain sensors for each and everything. We just attach the sensors, it collects some data, and then it transfers. So how we can integrate this IoT with this metaverse, or where it can be used, or how this Internet of Things can be used with this. Just I'm giving you a sample architecture which is used by a recent research paper here, where you could see different areas here. Where the right side we have some physical area. You have the sensors, communication, computation, and the cache memory, and you have one more human area, and then you have virtual area. So your virtual area is again partitioned into your engine layer, virtual layer, and virtual universe. The top level you have all your metaverse, your sub-metaverse and other things are there. But if you could see your engine layer of your metaverse, what are the major technologies that contribute to the engine layer of your metaverse? You could see 3D rendering, or digital twins, AI, extended reality, and blockchain. So 3D rendering, you could see it can create a virtual environment, or you can have some avatars. Instead of you, some avatars may be there, or some virtual services, virtual goods, or digital assets. All those things come under your virtual layer, and then your virtual universe is there. My topic is going to be with this engine layer, and I'm going to concentrate more on the engine layer today, where in the human area, you have different things where you use this metaverse. One may be for entertainment, or maybe for a teamwork, or for educational purposes, meeting, or family get-togethers. When this metaverse started gaining its popularity, maybe metaverse was there, all these avatars or Oculus devices, extended reality, augmented reality were in place. But after the pandemic, everybody started giving more importance to this extended reality or this metaverse. And you could see multiple softwares coming in, where there are virtual classrooms that are created, where if I can place myself in a classroom, even though sitting alone in a online class. Now we are all attending session in online, but I could see only thumbnails of you or people here. Maybe I could see the names or your initials, and only thumbnails are giving one or two videos I could see here. But what if I could see avatars instead? You can put your face and some avatar kind of character which can sit and which can simulate what you do, how you sit in your classes, or I can put a seating arrangement for you, which will give you a real feeling of where you sit in the class and attend, but still it is a virtual class. Then there are different softwares that came up. Maybe Google Meet, Zoom, and other things are also there. But still, we have certain softwares which will help you to visualize you sitting in a classroom, and then you are physically touching the board and writing in the class board along with your teacher. Kind of all these things are gaining popularity. Why? Because we are in a position where we cannot say that we have to go with conventional teaching. I have to go to a class and then learn. Rather, nowadays it is like most of the universities we follow hybrid teaching. It's like I'm not expecting our students to be present in the classes sometimes. If it is a hybrid mode, we do. Some of them, those who want to come and attend the classes, they can attend. Those who want to attend from their own places. Many universities are following the mode of hybrid teaching nowadays. And what we do, it's like we continuously record our teachings or the lectures that we go through, and then we do integrate with people, those who are sitting in the class. At the same time, those who are sitting online, they want to be with the class or participate virtually. These kind of virtual reality things that helps us. So how Internet of Things and this reality will help me? How it is going to help? It is one close technology that is with IoT and Metaverse is with the help of a technology enabler called digital twins. So digital twins, it started gaining more popularity. So what does the Blockchain Council says about IoT? You could see I have given some quotes here about from the Blockchain Council. I felt it good after reading this, then I thought I'll use here. So the Blockchain Council refers IoT as an important pillar of metaverse infrastructure. Metaverse is as such a technology that is gaining popularity, but what makes it more popular, or how it can, what is the technology that enables metaverse infrastructure? It is IoT. If metaverse and IoT are integrated together, say one example they have given, unlock new opportunities for industrial domain, individual needs and social requirements. So like this council has given some examples. So what IoT would do, IoT would be allowing all virtual spaces to seamless access of anything, or if you put some actuators or sensors to read a particular environment, it may be a temperature sensor or it may be some other sensor which continuously monitors about a particular place. So seamless integration can be given and it can interact with the real world. While what Metaverse will do, this part is done by IoT, or seamless access and interaction with the real world can be done by IoT devices. But while the Metaverse would provide the 3D user interface for the IoT device clusters. So there is one part which is the physical part, which literally studies or collects the data about environment or anything that is with the real world. That part will be taken care of by IoT at the same time. And 3D and other user interfaces device clusters will be done by this. So finally, integrating this, you will get a metaverse experience. So another example in a factory, if you could take where the digital twin of every machine has sensors. So we have digital twins, but digital twins are not actually, hope you all might be knowing about the latest things that are happening with digital twins. So most of the companies, whenever they go for a new product, not only companies, any sector if you take, instead of checking with the original products and then test it, rather what we do, we go with a digital twin. Suppose, for example, I'm going to come up with a new car model. Instead of building a model and then test it, what we do, it's like we create a digital twin of it, a virtual model of it. But within the virtual model, what we can do is we can place sensor data and then try to do. Or another example, I would like to say, I wanted to make my home smart. So how we do? Using IoT systems, we can do. Consider I have all appliances in my home. In my living room, what I would like to do, I may have a smart TV, I may have a music system, and I may have a Wi-Fi. Nowadays, you know all these devices, what you get in your home, or the appliances that you get for your home are smart. Or in another point, I could say it can integrate or it can be connected to the same Wi-Fi you are in. Hope you agree with me, right? Suppose you are getting a smart TV. Gone out those days where you had a big TV, but you cannot do any operation. But now what we do, you have a smart TV at your home and you have Wi-Fi also. What you do, you directly connect your Wi-Fi with your TV and you can what are the devices that are connected to the same Wi-Fi can cast. Say, for example, my laptop is here and my TV is also there. If I want to connect these two, I don't want any physical connection. Rather, they should be connected with same Wi-Fi. You all might be knowing about this. So, what I do without any disturbance or any physical connectivity, I can sit anywhere in my home and then I can interact with my TV as well as with my laptop, or even I can integrate my fridge or my washing machine, anything that can be connected with the same Wi-Fi. I have a dashboard in my smart TV where I can connect all of my devices, and then from there only I can, from my phone, say for example, I'm with all my Samsung products. I have a Samsung phone, I have a Samsung laptop, or I have Samsung TV, washer, everything. So maybe Samsung comes up with an app called Smart Things. If all your products are with Apple, you have AirPlay and you have things like that. So you can do AirPrint kind of, but none of them are being physically connected. But what I try to do, it's like seamlessly I'm getting it connected only with the help of the concept of IoT. But what digital twin will do, if I want to make my home smart, what I do, I'm not going to build my smart home first. Rather than coming up with the products, what I do with Unity or some other latest metaverse softwares, what I can do, I can simulate my home. We do remember that whenever you want to build a house, what we do before, we go with blueprint. Maybe an architect or a civil engineer will give you a blueprint before you start constructing your house. So he will give you a blueprint in a paper drawn with, this is your front elevation, this is how your stairs is going to be, this is the dimensions of your windows, and then this is your living room, this is your bedroom, or kitchen area, how it is going to be. Everything will be drawn to you, and it is given to you in paper or as a sketch. We call it as a sketch. But now what we do, before we construct a house, we get the home tour. We can experience how your newly constructed house is going to be. They will give you a device, a plus device where you can put it, and then it will take you a walkthrough of the newly going to be constructed house. So you can literally feel how this is my entrance, or this is my front elevation, this is going to be my parking area, and this is how my living room will look like, and this is how my wardrobes are going to come. And even the color combinations, whatever you are going to do, it is being replicated or it is logically created for you. And then you have an experience. It is not going to be new for you because you already experienced before even you construct your house. After constructing your house, you can relate with your movie that is created for your, or virtual tour that is created. You can do almost all the campuses. What we do, if you go to the website, if they wanted to visit the campus, no need to come physically to the campus. They have a virtual tour of almost every campuses where it will take you from the entrance gate to the end of your campus, right? So it gives you a feel. Similarly, digital twins, what we do here, we exactly create, this is my living room and this is my TV, but if I want to make it smart, what I'm going to do? These are all my lights, these are all my fans, what are the sensors I wanted to attach? Everything I try to put it there, and then I'll simulate it, or I'll check with a digital twin concept, and it will directly give me, this is how my home is going to look like. And I'll do a testing of all these things, and then everything works perfect. Then what I'll do, I will be going with the original product that I'm going to build. If any of the problems that you are expecting, what you can do, the digital twin itself will tell you that these are all the problems that you may encounter while constructing your original smart home. Then these are all the places where you need to check. All those things will be given by your digital twin. So that is what I was talking about, digital twins, what it will do. Digital twins will facilitate a seamless digital physical integration, and it will unlock you a new avenues for innovation. This is what we get from your digital twins. So we will give some examples of digital twins. So what IoT will do here along with the digital twins, first one is your data collection. In data collection, what these IoT devices can do, devices can constantly gather data about the environment or usage. So it may be any kind of information, it may be temperature, or it may be a CCTV footage, or any kind of sensor that you, or it may be a gas leakage sensor, whatever it may be. And then interconnectivity, then devices can communicate and work together. If, say for example, if this particular condition is happening, a triggered programming can happen. So they will communicate. If something is detected in your CCTV camera, what it does, it raises an alarm in your phone. So it communicates. So what is, which device is detecting certain things? Your CCTV is detecting some abnormality in its regular course. So that is being communicated to your phone or through an alarm or to other device. So we call it as, it is not machine to it is not human to human interaction. Rather nowadays it is machine to machine interaction is happening. So human to machine, machine to machine. So most of the IoT devices you could see machine to machine interaction is possible nowadays, and interconnectivity of these devices. And then remote access and control, you can control it anything from anywhere. That also you can do, and it is extremely connected world we can call it as. Now, digital twins and how we can leverage with IoT data. What we do first, sensors and data acquisition is important part of IoT, as you all might be knowing. Embedded sensors we have. What we do, every device will be embedded with some sensors. If you take a car, there are a lot of sensors that are embedded. Gone are those days where I will go to a workshop and then the workshop guy will see my car and then try to find out what exactly is the problem. But nowadays, in your car dashboard, you're not knowing what is the exact problem with your car, right? What it does, it gives you some warning. There may be some symbol that will be suddenly popping up in your car dashboard. You may not be knowing, you just Google it, it may say it is engine malfunction. But we do not know what exactly is the engine malfunction. How they do it, you take it to the authorized dealer. They'll also not say, they'll just connect your car to the system. What it will do, based on this particular problem, it will say there is a sensor. You have done recently a water wash, and because of that some water is sitting in some sensors and it is showing as a malfunction, and he takes it, cleans it and then put it works. So everything it's like based on automated systems, where even if you give it to somebody, I cannot take my Toyota car to some other showroom and then try to find out, because nowadays they're making it mandatory that I will go to my authorized dealer and then try to get it, because only they can find it out. They have a system. So they connect my dashboard or my car dashboard to their system and automatically for all the problems that I have. Or even sometimes what happens remotely, they can monitor how much of kilometer I have run and then what are the problems that I'm facing, whether my brake is in proper condition, or you have a sensor in your tires which says that your pressure is proper in your tires, or I need to top up the air in my tires. All these things are coming in my dashboard. So what happens is like everywhere these sensors are embedded, but all these things pass some data. Based on these data, we do some action. It starts from the very basic applications that we use. Even your water level controller. You have a water level water tank with your home, and then you put a water level tank controller. Almost every apartment or home we do this. And whenever the water level goes down, automatically the motor is switched on, and whenever the water is full, the motor is automatically switched off. But I'm not doing anything, there is no human intervention, but the sensor is communicating with the relay and the switch that is connected to my motor, and it automatically switches on and automatically switches off. How it is possible? It is all because of the sensor which is connected, and the sensor, whenever it detects that the water level is going down beyond the thresholds, then automatically it does. How it does? It is based on the communication protocols. We have message queue transport telemetry, advanced message queue transport telemetry, constraint application protocols. In short, we call it as MQTT, COAP, HTTP. So all these HTTP and other protocols are there for the internet, but now for Internet of Things, what we need to do is like we have to tailor or customize the different protocols that we have, and the existing algorithms or protocols that are there for your internet, like maybe your traditional TCP or UDP may not work for your Internet of Things. So that is the reason what we do. We all go for lightweight protocols like MQTT, COAP, and other things. Apart from that, we have the concept of APIs. So what we do is like nobody is creating different softwares for everything. Say if you take about talk about Zomato or Swiggy or Ola, Uber, everything you take it common. It's like they all use the APIs of Google Maps, but it is not their own proprietary product, but still it is used a third-party product. They use it within their app, or everybody is using a BHIL UPI. that is again given as an API that can be used by any third party. So what I try to tell, it's like, it's not the software industry or the way in which we develop software is not the same before. Now what we do, it's like everything has become like the concept of APIs. Anybody wants to use it is like the advanced level of cloud. Whatever you want to use, if you want to use software as a service, you can use platform as a service. You can use API as a service. If you want, you can use. Recently, MG has come up with the car electric vehicles. You could have seen EV vehicles like a Windsor or something. So many products that are coming where they have introduced the concept as battery as a service. They all got inspired from maybe cloud computing. We call it as PaaS, IaaS, infrastructure and software as a service. And now he has introduced battery as a service where I'm not paying for my battery, how much, what kind of package of battery that I wanted to use for my EV, electric vehicle. I can use it and I can replace it in my nearest center. So nowadays what we call it as, instead of everything as a service. So we are moving towards different types of technologies. So next we have data integration and processing, where edge computing plays important role. We are not doing everything is processed at the edge for faster process. And then we have analytics, streaming analytics. Instead of processing your normal queries, you are having streaming the query, or whatever stream of data, you can directly query it and then get it, and then different analytics are also possible. And the tools like AWS, Kinesis, and Azure System Analytics, they all allow digital twin to respond. So now, if you want to build a digital twin model along with IoT, what are the things that you need to do? What are the steps in building a digital twin model that we are going to do? It's like a 3D. What we do a 3D in 3D modeling, it's like we all know about 3D models, right? 2D, 3D, different models we have. So 3D modeling softwares, almost all your metaverse things can do a 3D models. So we have software like Autodesk or Siemens NX. Some of them are commercial, most of them, and then we have good amount of even Unity also can be used, or different types of softwares that are there, or real engines are there where you can create your 3D modeling things, and you create a 3D model and then you can do a simulation using a MATLAB or ANSYS or different softwares that are used for simulations. And then, as I told you about the different APIs and WebSockets, you can use any of the APIs or WebSockets that are readily available, and then digital twin is synced with real world changes in real time. So what are the things that we do? I have taken some, apart from that, one major thing that we have to do with this is like security and data integrity using this. Also, traditional encryption algorithms may not work because we are using all these kind of lightweight protocols. So IoT, there is another area of research, our major area of research is where we go with a lightweight encryption. Yes, we do have a good amount of cryptographic algorithms that we may use elliptical cryptography or DDoS, RSA. The power of your cryptographic algorithms may be very strong that it cannot be attacked, or attacker cannot decipher your text. Yes, but if it is for a standard system, we can employ such computationally complex algorithms. But all these IoT devices or edge devices, we cannot deploy such security mechanisms. So there are research that is happening in the lightweight security protocols as well, where we need to go with lightweight security protocols also. Encryption using your TLS or IoT for voice of IoT like Quantum and other things. We have lightweight protocols also. And scalability, and we need to, if I'm saying it is a digital twin, I'm using a digital twin for a factory, a blockchain thing. I need to add more number of products and other things. It should be scalable, right? So technologies like Docker, Kubernetes, so it enables flexibility and scalability for your IoT devices, which can be added or removed. And the data formats, it's not like HTML before. Now we have more standardized formats, and we are not going with the traditional databases where we use structured query languages. Now we are not with those. Still, it is there in certain applications, but most of the places what we do is like we are not going with traditional databases or structured databases. We go with SQLite or MongoDB, or we go with certain formats. The way in which we put your Facebook data is not structured, right? I may feel like, or my Instagram post or Facebook post, it's not structured. We put it like I may be sharing a reel, or I may be sharing a picture, or I may be sharing some text, or sometimes it may be a video. So what kind of text I need to take? Java short object notifications, JSON formats or XML formats can be used to ensure interoperability, because I may be using Facebook in my laptop, I may be using Facebook in my mobile, or maybe using it in my a tablet, but all will not have the same formats. But all these standard formats like JSON will help me to reduce and then put it and display it. So these are all the things that are going parallel. Having all these things with introduction, what I'm planning to take you through is IoT and digital twin applications. Manufacturing. So your production process, identify what are the different problems, or if you want to have a block, if you want to have a supply chain for your thing, you can always model it, which is my assembly unit. What are the things that I'm going to manufacture? What automation that I'm going to do? Say, for example, you're going to start with a cool drink manufacturing company. What are the things that you might be in need of? So you need to have certain automation and conveyor belts where there is a process where it should prepare your cold drink, then it should pour according to the quantity that you want. Say, for example, you may come up with different size of bottles, right? It may be 250 ml or 500 ml, 750 ml, or 1000 ml, for example. Excuse me. So what you are doing, you are planning. It's like you are coming up with different mechanisms. You are creating a digital twin where how your bottle travels in your conveyor belt, and where it is going to fill, who is going to put the cap, and how it is going to be sealed, then how as packages it is going to be sealed, and what kind of packages are going to be packed, or how it is going to the shipment. All these things you can simulate and then see, and you can create a digital twin of your factory that you're going to set up, or the manufacturing unit that you're going to set up. So this is another important aspect of your digital twin that we can do. So there are different use cases that we can talk about, and then main use cases is in healthcare. I know a company where it is trying to create a digital twin of humans. So normally in medical field, what they do, it's like if you want to test some medicines, what they do, they cannot be directly tested with, human beings. Rather, they will be doing it with rat or cat, something like that. They will do. But nowadays, what they are doing is like they are trying to analyze or simulate the nerves, the neural system, whatever a human body is having. They are trying to simulate it, and with the help of machine learning algorithms and other things that we do. Most of the things what we do, it's like it is based on the algorithms only we do, right? Not will say, for example, a very basic example we will take, where we use machine algorithms or some algorithms to predict certain results. Directly, if I wanted to check my random glucose level, what I do, I just prick my finger, take a drop of blood, I put it in a sensor, or we call it as AccuCheck or your blood glucose monitor. So what we do, there is a sensor which senses my blood, and then it calculates tentatively what is the amount of glucose level in my blood at that particular point of time. Nowadays, there are devices which says that there are different technologies that are coming in, where what we do is, instead of pricking, non-invasive glucometers are coming, where there is a sensor which I can just touch it. Based on my pulse, it says. But how I relate these two results, one is with blood and one is without blood, but still it is giving certain results. It is based on some algorithms. Or apart from that, you take the same example of your glucose level, where I do with a 3 months average. Almost every one of you might be checking, right? Whenever you are checking your glucose level or your sugar levels, what doctors are advising nowadays, it's like you may be taking your fasting sugar, and then you may be taking your postprandial. Why? Without eating any food, what is your blood glucose level that you're checking? After eating maybe 1.5 hours of your food, breakfast or lunch, you just check it. That is one thing. Apart from that, there is one more parameter called your HbA1c level, which says that the 3 months average of your sugar. But are we giving, if it is actually speaking the 3 months average of sugar, how it has to be done for the past 3 months, every day I should have taken the blood glucose level, literally, and then I will be taking up the average of the levels. right? But we are not doing it based on one single day that you give, but the mission algorithm or the algorithm which is implemented there, what it does some prediction saying that if your blood level is like this, and it might be like this for the past 3 months, your average would be like this. There are certain algorithms or formulas in place which is predicting. I'm not saying that it is accurate, but it is accepted worldwide. Similarly, there are so many things that are possible. You can create even a digital twin kind of, and then you can simulate how a body works, and then you can do it. So IoT and digital twin applications use cases are there in personalized medication. So nowadays you could see so many companies coming up with maybe your sugar fit or different diabetic reversal programs you see in marketing advertisements. You could see whenever you turn your Facebook or YouTube, you see people talking about your diabetic reversal. What they do, they put a patch on you and they continuously monitor your sugar for 14 days or 21 days period, and then they analyze what were the things that you eat which elevates your sugar level, and then your these sensors which are present on your arms or the biosensors what they attach with you will continuously monitor, and there is an app given to you where you can enter what you are eating, and based on your food habit how it is increasing, based on the stress level what you have, whether your sugar is increasing or not. There are different parameters in which it is analyzing it. Based on that, what they do, they give a personalized medication. Instead of before, how we do take medications, it's like, okay, once in a while you check your sugar level is this, so doctor will adjust your medicine, take one more tablet, or instead of 10 mg, you go for 20 mg, they try to adjust, or if you're into insulin, take 20 mg, then they'll say if it is not still under control, they'll say 30. But if you are becoming hypoglycemic, what they do, they will reduce and then they make it as 25. They'll do some adjustments, some 1 week, and then finally your dose will be adjusted for some time. But nowadays it is not the case where you can customize your medicine. One day I may take 500 mg of my metformin extended release, and next day I don't want to take it because my sugar level is less or my intake is less. My parameter says or my app says that your level is well within the control, no need to take any metformin today. So a personalized medication, it is possible with these kind of cases. Next, another important use case, what I wanted to discuss is on urban planning and smart cities, where the integration of your metaverse and IoT can be seen here. A short video, 2 minutes video, quickly you can go through. It is from City Zenith Corporation, and even whenever you are free, you can go through these kind of videos, and how without constructing a big project, they do it. How they come up with these kind of, see, apart from building it, they simulate everything. How the bridges are going to be, how the roads are going to be, what are the different areas that you are going to connect vehicles and people, how many houses are there, how people are going to commute, how will be the traffic within this community. All these things can be simulated with the help of your virtual reality, metaverse, and with the help of your IoT data. So they have built a lot of projects in a city and then checking how it is going to look like. So how energy can be saved or optimized. What are the different things that they can do for energy optimizations? We could see how they are doing it. I think it is done by Microsoft. One Azure digital twin platform is also there. There are so many other platforms that are available, but they're all commercial. I couldn't find any of the free software which can make a digital twin. Even I was trying that I can give a hands-on demo of creating a small smartphone digital twin, but almost all of them are with commercials. So I'm not promoting Citizen, just I wanted to show you how these digital twin applications and use cases are used. Next, another important sector is your energy or grid optimization or renewable energy management. how predictive prescriptive analysis of energy management can be done by your digital twins. These are all not real solar panels that I have actually deployed. These are all like, this is how I'm going to put my solar panels. And if I put like this, how much of energy my digital twin can generate, how I can use, how much of energy can be used, and how I can control, and how I can reuse it, how I can monitor it. See, these may be deployed in some other place, and it's not practically feasible for any human to be here in this place and then monitor. So, how a digital twin can help me to visualize how I'm going to set up, and then how I'm going to collect the data from this. So if you say it's like 90, instead of spending 90%, you could see it will cut down the cost. Even in Renault, we saw how much of cost we are cutting down by creating a digital twin instead of creating your own model, right? Similarly, every aspect, instead of creating your own models, a digital twin will help you to reduce so much of cost, is what we could see. So 2026, 70% will be managed by digital twins, is what they say, the panels. You could see the role of metaverse in this, where all these models are done 3D models that actually resembles the original models. So they create these models and then do it. So these are all some of the benefits. So predictive maintenance, simulation, optimization, improved product lifecycle management. What I was talking about so far about the digital twins is given in these slides. So another example is like treating a chronic heart condition, how with the help of digital twin is given here. So these are all some of the examples. What I thought it's like with the digital twins in different sectors, metaverse, IoT, and digital twins, how it can help is what I thought about my topic. And this deals about the same diagram as being explained how a patient background is monitored with a case study they have given. So I don't want to get into the case study. And these are all some of the examples which I wanted to talk about digital twins, metaverse, and IoT. If you have any other questions, you can ask me. I thought I would conclude my session because there is no point in